From Decontex, Mr. Tommy Verminck from Belgium. We look forward to hear you.
Okay, thank you so much for this nice introduction. And first of all, I apologize. So I'm from Belgium, so my Norwegian is very bad. So I will continue really in English. First of all, congratulations to the whole team of the Norwegian team of firefighters that fight cancer, because this is unseen for me. 250 people together, really with the same mind on realizing that the firefighters have a problem, and together we are here with the industry, with people from the academic world, the firefighters really try to brainstorm and to find solutions. So thank you very much. This is an honor for me to be here, and congratulations. So about myself, I'm the founder of Decontex, but more of this, I'm a scientist, and today I will, in this presentation, go with you through three important questions. So, decontamination of the fire PPE. So I will focus really on the textile part of the PPE, so not on the breathing apparatus. And three questions are key for me. Why should we do this? And should we really do this? And then, how to do this? Because indeed there are a lot of studies. And when to do this. So, first of all, the why question. If we look to, let us say, an outcome from a university study of the University of Leuven in July last year, they came out that now, today, there are 4 proven exposure routes. Because we all know that in the past there was really focus on inhalation, and so we have breathing apparatus. The gastrointestinal way, when do we, because everybody knows already which are the polycyclic aromatic hydrocarbons. This we have in our body if we eat, let us say, a black-burned sausage, but 2 routes were, let us say, underestimated. And this is, first of all, the percutaneous absorption route, of dermal absorption, and the absorption through the eyes. This study is, let us say, available. If somebody has an interest, I can send it to you. So after a long study, they came out that the route, the exposure route, absorption through the skin, is an important one to consider. And how did they test this? So they had a team of, let us say, 30 firefighters. And 10 of them were wearing contaminated gear coming out of a CFBT container test, so wood and burn, and they were cycling on a home trailer. And 10 other firefighters, they have, let us say, gear that was contaminated, but let us say, cleaned in a traditional way. And another 10 people, they had really a decontamination. And the university did biomonitoring, actually. So, let us say, if this is the moment of, let us say, they start wearing the gear, they start cycling, and they did urine tests between 4 and 8 and 10 hours after they were exposed. And what they found is really high, elevated levels of toxic compounds in the urine and in the blood. And as well, this is a PhD study that I can provide you. This is 8 years of study. Finally, it is proven, because there was a lot of controversy, if you are wearing contaminated PPE, is this a problem? Is this not a problem? Well, today, finally, we have a study that, let us say, builds that there is a problem and that we should do something. So this as an introduction. Let us say, if we, my slides are in the wrong way, sorry. If we talk on contamination or decontamination, I think it's very important to make a definition of contaminated. And let's say, according to the university, we have 3 types of contamination. First of all, this is the most known in the fire world, this is the chemical contamination. So not only polycyclic aromatic hydrocarbons, but we have dioxins, PCBs, cyanides, so different types of toxic compounds altogether, depending on what is burning. Because today, the types of burning has changed a lot. Imagine that this building would be burning. We have a lot of composites, a lot of tablets, a lot of computers. So the level of toxicity is, let us say, more than 10,000 times higher than, let us say, this building maybe 20 years ago. So we should consider the whole picture. What else do we have? Biological contamination. In times of, luckily post SARS-CoV, we all know what biological contamination is, so bacteria, viruses. Is this a problem? This is not a huge problem, but at the end, to hygienic reasons, it is good that we can now and then, let us say, remove that as well from our PPE, because at the end we are wearing professional PPE. And then there is the last group, and I found it because it's really the NFPA 1851, so that's the American standard for cleaning of intervention gear that focuses as well on physical contamination, and it was mentioned already in one of the previous presentations, let us say asbestos and heavy metals. So if we start with the first one, we started a project in 2014, and this was subsidized by the European Commission, so thank you very much to the European Commission. But they said, okay, well, what will you do, and what is for you decontamination? Because there were a lot of studies on how clean is clean and so on. So, of course, the first thing we did is we checked regulations. And there are regulations, because there is the European REACH regulation, and REACH is a regulation, not a directive. Why I'm telling this? Because a regulation is like a rule. This is that the member states have no choice, should we do this or not? No, it is a regulation. And what is REACH? REACH is a law that is defining the maximum amounts of toxicity. For example, if you make a new drink, what is the maximum amount? And for textiles, they are referring to Decontex. And I'm not sure if anybody here is familiar with Decontex. This is something that has been created initially by the German lab Hohenstein, because when the textiles came from, let us say, from the Far East to Europe, they contained a lot of toxic compounds. And they said this is a problem for the dermal absorption, so we will make a list with all toxic compounds and limits. So what we wanted to do in the project is to bring all the toxic compounds on fire gear to under this health level. But one key thing for us was we don't want any degradation of the gear, because fire intervention gear is quite complex. It has different layers. It has I always take some didactic materials. It has some outer layers. Inside, in the most of the garments, we have what we call a membrane. The Americans call that a moisture barrier. It's a kind of filter, and we have a lining. But more of that, we have zippers, we have tapings, we have reflective material. So cleaning fire intervention gear, it's not so easy. And what we see, I'm not sure in Scandinavia, but like in Belgium and let's say France, a lot of firefighters only have one suit. And the average price of a suit is between, let us say, 700 and 1,000 euros. So the longer that they can stay with the suit, of course, the better. So this was, let's say, the other goal in the project. So, if we look to REACH and Decontex, we see the list of polycyclic aromatic hydrocarbons. It's the same list that has been presented already 2 or 3 times. And we have actually the class 3. Firefighter gear is in the class 3. Why? Because this is a type of textiles that has an indirect contact with the skin. And the first class is clothing for babies. Why is this stronger? Because babies have a skin which is thinner, and of course the rules are stronger. So if we look to REACH, the regulation from all these toxic compounds, we can have maximum 1 milligram of this compound, for example benzoylpyrene. The researcher explains already that this is a class 1 in the according to the rules of the International Agency for Research on Cancer, so proven carcinogenic, 1 milligram of the compound per kilograms textiles, and in total we can have 10. So the sum of the 24 polycyclic aromatic hydrocarbons together. So if we check now a real test, so we took a garment that was one time in a container test. You see the 4 layers, the outer shell, the membrane and the lining, and we sent it to the lab in Belgium. Centex Bel is like a notified body for textiles, and with thermal extraction they can measure, let us say, quantitative the amounts of toxic compounds. So what do we see here? This is a spectrum of a garment that was in a strong, in a heavy contaminating intervention. So what we see is we have the whole list of polycyclic aromatic hydrocarbons. And what we can see here, the blue line is what the lab found on the outer shell of the gear. The orange line is what we found in the membrane, in the filter. And the light gray line is what we found on the lining. So I think this is logic, because the membrane, Gore-Tex or Sympatex or Alpex, it doesn't matter, is the most closed structure in the garments, so can absorb the most of toxic compounds. So I think this is a logical outcome at the end. At the other hand, that layer is the most difficult one to clean, because the garment manufacturers, one of the reasons that they are putting a membrane in the garment is to, let us say, to make sure that you keep it dry. So you can never pull water through a membrane until you break it. So if you try to clean the real inside with water, it's not so easy. I will not say impossible, but not so easy. So what did we want to do? Reduce everything to under, let us say, the health number. He's there. And let us say we managed to do this. So for example, the total, you remember it is 10, and we found, or the lab found, 48.5. So that means we almost have 500% over the standard. And this is maybe something interesting to explain. If we go to, let us say, to companies like BASF or something, and we talk to the prevention advisors who are in charge of occupational health and safety, they allow maximum 2% deviation on the workplace. The firefighters are walking around with 500, 600, 700, 800% higher than, and still we found people, as well in Belgium and Germany, wherever, that say, is this really a problem? Okay, it is a problem. Of course, what we try to do is to come to this amount. And I will explain you how we did this, because it was not so easy. Actually, this is just, I don't know if you know what this is. This is a microscopic view of a filter of a membrane. So normally you can see all the particles inside, and after decontamination, it is, let us say, out. So we actually did a lot of studies with different types of, let us say, of cleaning, and we came out by an old extraction technology that is used a lot now in the United States to take the CBD oil from the cannabis. The cannabis oil is very popular in cosmetics and in other areas as well, like that. So we learned from these guys, because they're used to take the good things out, and we took the bad things out. So how does that work? So the previous speaker explained us the 5 steps. So this is according to the silver circle. And we have here another principle, very short, how that works. So this is a machine. You should realize it's like a very big washing machine, 12,000 kilograms, and I will tell you why. Because we play with pressure. So first step, very short. You open the door, the garments go in, close the door. In the first step, the drum becomes vacuum. So all the air is going out. And then we replace the air by CO2. Everybody knows CO2 because it was or last night in your beer, or it will be tonight in your beer. So it's the same CO2. I'm telling this because a lot of people think CO2 it is dangerous. No, drink it every day. So CO2, we are there. CO2 goes in the drum, and the CO2, which is a gas, goes really between the fibers of, let us say, the textiles. And then in the next step, we pull up the pressure until 50 bars. And what happens then? The CO2 changes from the gas phase to the liquid phase. And we have all understand what is dirt. We have textiles and dirt. This is bound to each other with forces, physical forces, van der Waals forces. So the gas is between the textiles and the dirt. The pressure goes up, and we break the forces between the dirt and the textiles. Okay. In the next step, the drum is turning around very slow, 1 RPM, 1 round per minute, so that the textiles are just fall over and the dirt is going out. But this is not the main problem, because the studies learned us that all the contaminants are not on the outer shell in the lining, they are here in the filter. So what did we design at the end? Let us say in the new machines, we put there a storage tank where we have 1,000 liters of liquid CO2 and the distillation tank. And we pull 9 to 12 times all this liquid CO2, which has a very low density and viscosity, so it can penetrate the membrane, can go through the membrane. We push it very slowly through the membrane. The CO2 is recycled, the dirt is going out, and we come to wonderful, let's say, results. So, this in a nutshell how the CO2 extraction technology works. It has some advantages because it is a short process, 25 minutes. The gear is coming out dry, so you don't have to dry anymore. And we will see, if we talk on biological contamination, that we are on 15 degrees, which can be an advantage. So this is how, let us say, our clean room looks like, very short. I will go very short in that one, because this is the latest test done in Germany with a big fire school, Weeze, maybe you know that one. And we were not only focusing on the polycyclic aromatic hydrocarbons, but on 36 groups of toxins. And I will just present you the outcome. So if you look in total to the, let us say, just for your explanation, so we had 48 suits. 12 were tested on 6 places by the lab Rubenstein, okay? And they took the average, so after contamination, we had around this amount, okay? Then we asked Rubenstein to clean the garment according to the standard of industrial cleaning. There is a standard, an ISO standard 15797. And they came, so a partial reduction. And then we collaborate with a specialized laundry, because of course most of the laundries they can clean much better than the standard, which is normal. They came here, but whatever they did not succeed reaching the quite strong Decontex level. And of course, at the end, we were very happy that Rubenstein constated that we are there. So this is the latest test. It is significant because it is 48 times 6 samples. So this is enough, let us say, to make conclusions. So very short, the conclusion of Rubenstein. What did they say? Okay, the garments from Weeze, they have toxic amounts of 7 to 8 times above the health level. The ISO standard fails completely in reducing toxic components. The specialized process is able to do a partial decontamination, so the textile part, this part, and let us say the Decontex technology did everything. So this is the latest outcome. This study is, I think, 3 weeks old, and let us say we are happy about that. Very short, because I see time is running. What is biological contamination? In the world of biological contamination, we have 7 groups. And they are ranked here from impossible to inactivate or to kill prions, nobody can do, to very easy to, let us say, inactivate. If we look to group 7, this is the group with viruses that we know, but that we don't like. HIV, herpes, SARS-CoV, big names, but at the end, if you clean on 45 degrees, they are not dead, because viruses don't live, but they are inactivated. We found a bigger challenge in group 6, because the group 6 is the group of bacteria that are the base of what we call the smell of sweat. And we found this more in gloves than in shoes. Maybe this has something to do with the Belgian firefighters, I don't know this, but so this was a challenge, because a lot of gloves has a combination between aramide fibers and leather. And we all know leather on high temperature with water, this is really impossible. So we were able, and normally if you want to kill them all, you should clean around 90 degrees. And that is really, let us say, has a big impact on the PPE. So we are able to clean all these bacteria here, so to, let us say, to kill the bacteria on 15 degrees, which has, of course, an advantage. Is this necessary? It's, let us say, a hygienic aspect. Okay. And of course, we have certificates on killing of COVID and so on. The last group, we were quite deep in it because, okay, asbestos, there's not something like just asbestos. You have different types of asbestos and particles and fibers and so on. And you have a big group of heavy metals. So again, what did we do there, or what did the lab do? They put different types of asbestos on the different layers on the fire gear. And in the residue of the Decontex LCO2 machine, we could find, or the lab could find, the same amount that was on the gear. So we have a check there from the lab, so this is just a part of the report. But you can see on the identification, there was 0 asbestos found, which is important because if we look to the list of REACH and Decontex, what I mentioned before, the maximum allowed level is 0 to asbestos. So, okay. So, what did we do during the different, let's say, years and months? We tested some gear of, let's say, the premium brands you see on the screen, different times, 100 to 250 times, and we saw that there is zero negative impact on the physical textile parameters, no shrinkage and so on, which is, of course, a nice benefit. When to do it? So, this is not an exact science, because normally you could say, yeah, after every heavy contamination, every time. Yeah. Some said, listen, you should do decontamination if your filter is saturated, but you cannot measure this. So, there is like a rule that is used in the big brigades, like Berlin, Paris, Amsterdam, Brussels, and so on, so that all the gear is 1 time a year, it comes in the full decontamination process. And they asked for a certificate, so that everything is out. And after every heavy contamination, fire intervention. And then your question would be, yeah, but when is this heavy contaminating? This is the experience. Most of the times, how does it work? If the firefighters go, for example, with 6 or 8 to the intervention, there go 4 in the fire, 5 and 3 stay outside because one is the driver and so on. For the 5 persons inside, the officer decides, for you starts now the decontamination process. But there is no exact science on this. This is my very last point. We built everything today in a clean room. And I don't know if everybody's familiar with the clean room. The clean room are different chambers which are in overpressure. So every 2 minutes you have new air coming in. And this has for us 2 reasons. So to avoid cross-contamination, because we give a certificate to the end user, to the firefighter, when the gear is coming back, that it has a full decontamination. So we cannot do this if there could be contamination in the clean room. And the second part is to prevent the workers, because today we are all firefighters or related to the fire business, let us say, and we understand that for firefighters there is a problem. Yeah. But for the workers in the laundry that are touching with their hands every day the contaminated gear, for the stitchers that are doing repairs, this is not serious. So we built a clean room and we are stating that we only repair garments after decontamination, because a stitcher you cannot give gloves and so on and so on. So, okay, this is just figures. A clean room can, let's say, there are small and big clean rooms, from 10,000 garments per year to 150,000 garments a year. And if things go well, we have now a 1-minute video just to show you. decontamination at the inside. So this is when garments are arriving in cleaning action. So these are the treatments, because if they are contaminated, you can see the water cannot reach inside. You can clean very well the outer layers. Garments have a pre-treatment, they should be, let's say, pre-dried. And these are at the end of sheets, actually, and 9 to 12 times clean completely the inside of the garment. After that, we will do quality control and so on, because this is not necessary preparations. Labels, certified, and back to the fire service. So, this is, sorry, it was a German, but it is a movie from the German colleagues today. So we, let us say, in the clean room in Belgium, we had around 85,000, let us say PPE, sets of PPE that we maintained. And this was, let us say, mainly coming from this area. So unfortunately, these are contact details from areas which are not here. Scandinavia is under the others because the service is not available today in Scandinavia, unfortunately. But if somebody would have an interest to learn more, to partner, to do a test, we have Mr. Stubbe, which is, there on the back, so you can contact him. We are staying until, let us say, Friday, if there would be any questions. So just to end up, and then I go back and I will shut up completely. So, which is important? To summarize, when we give gear back to the fire service. Firefighters, what was, let us say, in the first speech as well of, let us say, the person that opened the conference, yeah, they risk a lot. So it is not serious that they can have a chance that they get contaminated. And not by the PPE that should protect them. So what we recommend is to start maybe once a year, maybe less, but to now and then, a full decontamination, to empty the filter. And the guarantees that we have there is first, or that the firefighter should have, is first on the helmet, that a full chemical decontamination is there, not like minus 50% or 60%, no, there is a level and it should be under that level. This is the safety level. Hygiene, that if you have bacteria, by coincidence, maybe virus, that they are killed from time to time. They will not make you ill, but it's not normal that it is on professional gear. That, so quality control is done, because we all have garments, when they are new, they are CE certified, EN 469, but is there a control when the garment is 3, 4, 5, 6, 7 years old? We should do that, according to the PPE regulation, but maybe here, but in Belgium I can tell you, and in Germany it is often done. Yeah, sustainability. Of course, every technology has its value, but if we can choose between, let us say, a sustainable solution and a less sustainable solution, I think it is important. The process is verified, and in these days, with interesting meetings like in Glasgow and so on, the latest days, I think the environment is important. So the CO2, yeah, is CO2. There is enough CO2, there is not enough water. So if we can, let's say, replace a part of all what we clean in the technical textiles by, let's say, CO2 neutral or by environmentally processed, I think this is something to consider. So references out of the firefighters and the industrial world, not so important. And so, that's it. Thank you very much. If there are questions, I'm here in Bergen until Friday, so that's my email. You can always send me an email. The movie and the presentation will be available, so thank you so much.